Good morning. This is section 5.5, Simplifying Polynomials. We're doing page 224, number 1 through 53, odd. Okay. We are simplifying polynomials today. Okay, so we've talked about a monomial. Okay, that means one term, single term consisting of numbers, variables, and or whole numbers. Numbers, variables, and or whole number exponents, okay? So for it to be a monomial, it has to be a whole number exponents. And a polynomial, so we talked about 7x squared, 3m, 10ab squared, c. It's numbers and or variables tied together by multiplication. These are all monomials. Now, I do want to look at this last part where it says whole number exponents. So if I had, 4 over x squared, that would not be a monomial, because if I were to write that not in fraction form, it would be this. And the exponent is not a whole number, it's an integer. Okay, so that would not be a monomial, but the rest are, because these are the rules. So one of the rules is whole number exponents. Now, monomial means one term, polynomial means many terms. Many terms, more than one. An expression consisting of two or more monomial terms that can't be combined. So two or more terms that we can't combine them. Sorry. We have different kinds of polynomials. Remember, a polynomial has more than one term. It has many terms. The first kind of polynomial we're going to talk about, we've briefly talked about, it's called a binomial. What do you think a binomial has? It has two terms. Here's an example. All of these notes you should be writing. Okay, these are more examples of binomials. 2x plus 3, that could be a binomial. X plus 1. And the second type of binomial is called a trinomial. These will become your new best friends. You will be sleeping with them, eating with them, dreaming of them. Trinomials. This is something with three terms. Okay? 3 terms. It has an x. Notice this one has an x squared, x to the first, and a 4. Okay? Pause the recording and make sure you have all these notes. All right, identify each expression as a monomial, binomial, trinomial, or polynomial. I'm going to give you a minute, pause the recording, and let's go through the answers now. So the first one is a binomial, and that would also be a polynomial. So it's a binomial, most specifically, and a polynomial. The second one is a trinomial and a polynomial. The third one is just a monomial. The fourth one is what we call, we don't have a special name for 4 terms, so it is a polynomial. The next one, number 5, is a binomial. This next one is a trinomial. Oh, binomial, and it's part of the polynomial family. And the last is a trinomial and a polynomial. State whether each expression is a polynomial. If so, state the number of terms and the coefficients of each. Okay, I'm going to remind you, the term ends when you see the plus or minus sign. And also, it the coefficient is the number that comes before. So let's pause the recording and try the next 6 on your own. Now let's check our work. So this is a polynomial there are 3 terms, and the coefficients are 1 and -3. Number 2, it is a polynomial. It has 3 terms, and the coefficients are 5, -1, and 8. Okay. Number 3 is not a polynomial. Number 4 is a polynomial, and there are 1, 2, 3, 4 terms. The coefficients are 7, -1, and -4. Number 5 is not a polynomial because 4 over t squared is really 4t to the -2, and -2 is not a whole number exponent. So we would not call it a part of the polynomial family. However, if t to the 4th is in the numerator, it is a polynomial. So it can be in the numerator, but not in the denominator. And there are 2 terms. And the coefficient here is actually, there's a 1 in front of this. So this would be 1/3. Okay? Your coefficient would be 1/3. We call this last term with no variable, we call it a constant term. So it doesn't, I guess by rights, it would be x to the 0, but it doesn't, a coefficient's really the number that comes before the variable. Okay, standard form of a polynomial. Standard form is where we put the terms in order of the exponents. So the term is written basically in order of the exponents, from the highest exponent to the smallest, in decreasing order. Please take notes. Non-standard form, here we go, they're just in any order. We look for the highest exponent, and that would be -x to the 4th, so that gets written first. Okay, we're going to put this in standard form. -x to the 4th has the biggest exponent, so I write it first. Oh, wait, whoops, I didn't see that. Sorry, 7x to the 5th. Then we go with -x to the 4th because that's the next biggest exponent. Then we go with 4x squared, positive 4x squared. The sign travels with it. And then we go with -3x. And last but not least is our constant term, plus 8. It has a positive next to it. We don't write it. Now, and that would be the reason why 8 goes at the end, because if this is x to the 0 power, that really, x to the 0 equals 1. So 8 times 1 is 8, right? And so that's why it goes at the end. Okay? But it's not really, we don't say it's a coefficient. Okay. So today we're going to write these polynomials in standard form. Take a minute and go. Now let's check our work. Number 1 should be 5y to the 4th plus y minus 2. Number 2 should be 2m to the 5th minus m to the 3rd plus m minus 6. Number 3, 4t to the 3rd, no, whoops, didn't see that, negative t to the 6th, 4t to the 3rd, positive 8t squared, positive t, and negative 2. Number 4, negative 2k to the 4th, plus k to the 3rd, you have to bring its sign. Whatever's to the left of it is the sign that travels with it like a suitcase. 9k squared and negative 3. All right, so that's what we call standard form, when we go from the largest exponent term to the smallest exponent term. Okay, simplifying polynomials. So here we're going to sort these like we're sorting tiles. When you were a baby and they said put all the quarters in one pile, put all the nickels in a pile, put all the dimes in a pile, or better yet, put the buttons in a pile, the Legos in a pile, it's sorting. So we sort them and we put them with their lead coefficient, okay? So notice the x to the fourths, I'm going to take the largest one, 7x to the fourth, and 3x to the fourth. And how many x to the fourths are there? The only thing we do is we add the exponent. I should do this. We add the we add the coefficients. So that would be a 10x to the fourth. Now, how many, do we have any x to the thirds? No. So the next biggest one would be an x to the second. Okay, so here, let me go with a different color. I've got negative 2x squareds and positive 3x squareds. That makes positive 1x squared, right? Positive 1x squared. Next one we have is our x's. So I've got only a positive 5x. There's nothing to combine it with. And then we have our coefficient plus 9. So we've got to put them all down. And we've got our coefficient plus 9. There we go. So that is simplifying polynomials. Now, if these were tiles, okay, this is what we call a 1 by 1 tile, right? If I have a measurement like this, we know that that's 1, and I go like this, I'm going to call this x. We're going to call this 1 times x is an x tile. Well, what happens if I have an x times an x? We get what's called an x squared tile. And if we have a x times an x times one more dimension, x, 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 we end up with something called x cubed, okay? So as we're simplifying, what we're really doing is we're just taking all the square piles, which are called x squared, and putting them in a pile. We're putting all the x cubes in a pile. I don't know what the x to the fourth would look like. We're putting all the x tiles in a pile. We're putting all the 1 tiles, these are the coefficient tiles right here, in a pile. So, again, when we simplify our polynomials, we go from largest, I think my PowerPoint does it in 2 steps. I think just go from the biggest to the smallest and put them in order. That's it. Okay. So, pause the recording and try the next one on your own. Now let's check our work. Okay. Okay, let's check the next. 4 to the thirds, we're going to have negative 5 a to the thirds. Remember that negative a is really like a negative 1. 6a squared. Oops, sorry, I went too fast there. Minus 7a. Okay, let's try the next few. Simplify the following polynomial, write it in standard form. So let's go with the largest one. Well, I'll go with negative 4m squared and 7m squared. See, here's where they're doing it in 2 steps. I wouldn't have done this. I just go right to standard form. Let's not. I would have gone right away. My first step, I would start with my, that makes 3m squared. And then I would go to my 3m, and positive m, that makes positive 4m, and then I have minus 6. So I would just always start with your biggest exponent. Okay, try the next two. Now let's check our work. All right, so this is no different. All we're doing is basically finding the perimeter. Okay, when we find the perimeter, we just add the sides. So I'm going to start with my perimeter is equal to side 1 plus side 2 plus side 3, right? In a triangle, perimeter equals side 1 plus side 2 plus side 3. And now we're just going to combine our like terms. I've got 2x, 1x, and 3x. That makes 6x. And then I've got 4 minus 1 is 3. Okay. Now try the next one. It's a little bit tricky. That's as far as we can go. We can't simplify it anymore. We'll never know what x is. Okay, so now this one's tricky because we don't know the measurement, but we do know that this other small side is 3a. This is 3a, and the whole thing is 5a. So and we don't know this measurement, but we know the whole is 7 and the small part up top is 3, so that has to be 4a. Okay, so now we can add up our perimeter. Oops. Sorry. There we go. They're all a terms, so 5 plus 3 plus 2 plus 4 plus 3 plus 7 equals 24. They all go in the same pile, like the same x pile. Try the next two on your own. Now, hopefully you realize that this also is 2 times 3x plus 4. And this is 4x plus 1. So we are adding up 4x plus 1 plus 4x plus 1 plus 2 times 3x plus 4 plus 2 times 3x plus 4. Now notice I have some distributing to do here. So that would be a 6x plus 4 plus 6x plus 4, plus 8. I didn't distribute here and here. And then I'm going to just kind of combine these because I'm running out of, I don't want to write so much. That's another 8x plus 2. Now we're going to put all the x's together. 8x plus 6x plus 6x. That's 12x plus 8x. That's 20x. And I have 8 and 8 is 16 plus 18. Let's see if I got this one right. It's a lot of x's. Yep. Okay, so one of the things they did is they just did 2 times each side. And that's something we can do too, probably a little easier. Now, I do expect you to do this. This is not mental math. This is the work that you are showing, okay? And you do need to write the question, okay? So we're going to try 4 times x and 2 times x plus 1 for the next one. Right? And there we go. Okay, last part, degree of a polynomial. So the degree of a polynomial is the sum of the exponents of the variables, okay? So we might call this a 5-degree monomial. The next one is we're just adding the exponents. 11, 12, 11 and 3 is 14. The degree is 14. The next one is 2, 1, and 4. Remember, don't forget that b has a 1. So it's 7. Okay? And 23 is a 0-degree polynomial. So, or of the term, sorry, that's of the term. Now, if we look at the highest degree reached by any of the terms, so if the highest degree of the polynomial is the highest term. So notice here, this is 3, this is 2, and this is 0. So this is a 3rd degree polynomial. Okay, a 3rd degree polynomial. So we're going to, again, I'll go to the one right below it because that's the direction. This is 6, this is 9, and this is 12. So this is a 12-degree polynomial. Okay, try the next two on your own. Okay, let's check that work. And that is our lesson.